All right, so I get a lot of questions about completing the square. So let's go over what it means to complete the square and some use cases. So, completing the square is something you tend to learn in high school as maybe a way to solve quadratic equations. And there's always this little phrase that goes along with completing the square, which is half the middle term squared added to both sides. All right. And there's not always a good explanation as to why you do that and why it works. So let's start with that. So when we talk about completing the square, we're talking about making a perfect square trinomial. So what is a perfect square trinomial? Let's take a look at that. Oh, I've got the wrong color. Hang on. Actually, I guess I could do this in purple, but I would rather have black. All right, so what is a perfect square trinomial? Well, a perfect square trinomial is something that factors into something like that, x plus p squared. Right? And if I were to multiply this out, so remember to multiply that out, that means you have x plus p times x plus p. And when I multiply that out and combine up all my like terms, I end up with x squared plus 2px plus p squared. Now, if we examine this trinomial and we examine the factored form of this trinomial, you can see that it is pretty much all dependent on p. If I know p, then I know everything. So if I have, let's say I have a quadratic equation that I want to solve. So let's say I've got x squared plus 6x minus 3 equal to 0. And I want to solve this by completing the square. Right? Well, I need to change this, which right now is not a perfect square, into something that is a perfect square without actually changing the solutions to the quadratic equation. So I am going to look at the first two terms, and I'm going to use the first two terms, the squared term and the linear term, so the quadratic term and the linear term. So this is the quadratic term. This is the linear term. The -3 is the constant. So I want to keep the quadratic term and the linear term on the left side of the equation. I want to move the constant term over to the right. So that will give me x squared plus 6x. Now I'm going to leave a little bit of room. And when I move the -3, when I move the -3 from the left-hand side to the right-hand side, it becomes positive, right? Because I'm adding it to both sides of the equation. Now, what I want to do is what I have on the left is not quite a trinomial, right? I've only got two terms, so it's a binomial, but I want to turn it into a perfect square. So that means it has to have the form, excuse me, x squared plus 2px plus p squared. Well, I have this term, right? I have this linear term here. That's my 6x. So my 6x is the same thing as 2px. So that means that 2p is the same thing as 6. So if I solve this equation for p, p is 3. Right? And then what I need here is the constant term, which is p squared. Well, I can get that by squaring both sides, right? Square p, square 3, which makes p squared 9. So that means if I add a 9, let me change my color up here just for a second. If I add a 9 in here, all right, my left-hand side is now a perfect square. But I can't add a 9 on one side without also adding it on the other. So I have to add that 9 to both sides. All right, so that's where, think about this for a minute, half the middle term coefficient squared added to both sides comes from. All right, it's all about that p. Now, thinking of it this way and writing it out this way, I have very little thought that I have to put into the next step, which is now I have to factor this. But I know it's a perfect square, right? I know it's the same as this up here. All right, x squared plus 2px plus p squared, which means it's going to factor into x plus p squared. Well, I know what p is, right? P is right here. So that means my left-hand side is going to factor into x plus p, which is 3 squared. And my right-hand side, I'm just going to add 3 and 9, and I'm going to get 12. All right, now that I've gotten this far, I can finish solving the equation, which we may as well do. Let me come up here. All right, so now we've got x plus 3 squared equals 12. All right, so I've completed the square on it. Now to solve it, all I have to do is, right, we're going to square root. We're going to square root. So on the left-hand side, we get x plus 3. On the right-hand side, remember, anytime you impose a square root, you have to say plus or minus. And then the square root of 12, right? Let's look at this for a minute. The square root of 12, that would be 4 times 3. So that would be the square root of 4 times the square root of 3. And the square root of 4 is 2. So it'd be plus or minus 2 square root of 3. And then you just subtract a 3 from both sides. So we get x is negative 3 plus or minus 2 square roots of 3. And this is your solution to the equation. Okay, so we can get that by using this process of completing the square. Now, the example that I gave you didn't have a leading coefficient. All right, so when you have a leading coefficient, there's a little bit of extra that you have to do. All right, so let's label these. Let's make this example 1. All right, so let's come down here. We'll do example 2. And same thing, I'm going to solve a quadratic equation. I'll get into some of the other applications in a minute, but let's take a quadratic equation. 2x squared plus 2x minus 1 equals 0. All right, now I have a leading coefficient that I can't factor out. All right, at least I can't factor it out of the entire trinomial because 1 doesn't divide by 2. So I'm going to start this one just like I did the other by moving the constant term to the other side. So I've got 2x squared plus 2x, leave some room, equals negative 1. Now I can't complete the square if I have a leading coefficient. So I have to factor that leading coefficient out. I'm going to do it after I move the constant. You're always going to do it after you move the constant. So I'm going to take the 2 out here. All right, now at this point, if I want, I can divide the 2 out. However, if I don't want to have to deal with fractions as I'm going along, I might want to wait on that. All right. Which way do I want to do this? I guess, you know what? Let's divide it out at this point. All right. So I'm going to divide both sides by 2 because I'm solving the equation. So if I'm solving the equation, I can do that. Okay. All right, so now my middle term coefficient is 1. So that means that 2p equals 1. which means p equals 1/2, which means p squared equals 1/4. All right, so all I'm doing to get from 2p equals 1 to p equals 1/2 is I'm dividing both sides by 2. To get from p equals 1/2 to p squared equals 1/4, I'm squaring both sides. 1/2 squared is 1/4. All right, so 1/4 is what I'm adding to both sides. So plus 1/4. Now this is positive. Wait a second. Sorry. We added 1 to both sides. It's like, wait, that's not going to work. We added 1 to both sides. Okay, so I add 1/4 to both sides. And then again, I've got fractions in here, but you know what? I really don't care because I've got all the pieces I need. I know the left-hand side has to factor into x plus p, right? So x plus p is 1/2 squared. On the left-hand side, I've got 1/2 plus 1/4, that's 3/4. Right? And now I can solve this equation. May as well finish it off. So x plus 1/2 squared equals 3/4. So I have to square root both sides of this. Remember, when you do this, it's plus or minus. All right, so on the left-hand side, I'm going to get x plus 1/2. On this side, again, I want to simplify this a little bit. I've got a fraction here. So this is going to be plus or minus the square root of 3 over the square root of 4. And the square root of 4 is 2. So this is going to be plus or minus the square root of 3 over 2. So plus or minus the square root of 3 over 2. And then I subtract the 1/2 from both sides. And I get x equals minus 1/2 plus or minus square root of 3 over 2. So you could leave it like that, or you've got a common denominator. So if you wanted to, you could write this as minus 1 plus or minus the square root of 3 all over 2 that way. Either way, they both mean the same thing. All right, so again, completing the square in order to solve a quadratic equation. All right, so that's one reason why you might want to do that. Another reason that you might want to complete the square is, let's say you have the equation of a parabola. So I've got y equals 3x squared minus 6x plus 2. And I want to know what is the vertex. All right, there's a couple of different ways to find the vertex. One of them is to put the parabola into vertex form. All right, so vertex form is y equals a, x minus h plus k, and then the point hk is the vertex. You get a lot of other information out, but I'm not interested in that right now. Right? Now notice there's a difference here between what I did in the last two problems and what I'm doing in this problem, in that I don't have a conditional equation, right? I'm not looking for what values of x satisfy the equation. All right, there's an infinite number of values that satisfy this equation. Every value that lies on the parabola that is drawn out when you graph 3x squared minus 6x plus 2 is a solution. So that's not what I'm looking for. So what that means is I don't actually have two sides to my equation. I mean, I do, but I don't have a workable side. So what I'm going to do is, instead of moving the constant over to the other side, I'm just going to move it out of the way. All right, and I am going to look at this. And inside the parentheses is where I want to complete the square. Now again, I've got a leading coefficient here. And if I've got a leading coefficient, I have to factor it out. So I'm going to have y equals, I'm going to take the 3 in front, and then I have x squared minus, when I divide 6 by 3, I get 2. All right, so notice I'm only working with the first two terms here. All right, so now I have it in the form that I need to complete the square. All right, so my linear term coefficient is -2, so that means 2p equals -2. I divide both sides by 2, and p equals -1. And then p squared, I square both sides, and I square -1, and I get +1. So +1 is what I need to make a perfect square trinomial. But I have to be careful here because I don't have two sides. I'm not adding something to both sides. So adding something to both sides keeps the equation balanced. Another way to keep the equation balanced is to add 0. So I could add 0 by adding 1 and then subtracting 1. All right, so by adding 0, I have not changed the equation. I've only changed what it looks like. So now I can take the perfect square trinomial part, and I'll leave a big set of parentheses there. X squared plus 2x, I'm sorry, x squared minus 2x plus 1 is going to factor into x minus 1 squared, and then I still have a -1 hanging out there and a +2. All right, so I've done everything inside that set of parentheses. I have completed the square and I've factored it. All right, so the only other thing I need to do is get rid of my double parentheses. So that means distributing this 3. So I end up with 3 times x minus 1 squared minus 3 plus 2. All right, so y is going to be 3x minus 1 squared minus 3 plus 2 is -1. All right, so now I have my parabola in vertex form, so I can read the vertex off, right? The vertex. All right, so it's x minus h, so x minus h is x minus 1, so h is 1, plus k, and I have -1, so that makes k -1. So there's my vertex. All right, so being able to take a parabola and put it into vertex form is another reason you might want to complete the square. Now, there's other ways to do that. All right, and I'm sure a lot of you are yelling at me right now that there's other ways to do that that might be simpler. And you're right, there is. I'm not going to show you that, though, because that's not the point of this video. But there are, what the heck happened there? I don't know. Okay, but there are things that you can do that require completing the square, and legitimately there are no other ways to do it. All right, one of them is to take a conic section, so a circle or an ellipse or a hyperbola, and put it into standard form. Okay, so let's do a circle. Circles are nice. So let's say I have the equation of a circle, which is x squared plus y squared plus 4x minus 6y minus 3 equals 0. So this is the general conic section form, right? You got your squared terms, you got your linear terms, you got your constant term, and it's all equal to 0. All right, you can tell it's a circle because x squared plus y squared. If the coefficients of x squared and y squared are the same, then you've got a circle. If they're different and they're both the same sign, then you've got an ellipse. If they're different and they have opposite signs, you have a hyperbola. All right, so this is a circle. Regardless of which conic section you've got, the process to put it into standard form to find things like the center and the foci and the what do you call it? The major and minor axes is the same for whether it's a circle or an ellipse or a hyperbola. All right, so what I want to do is I want to group up my x's and my y's. So I'm going to put x squared and 4x together. I'm going to leave some room. I'm going to put y squared and minus 6y together, and I'm going to leave some room. I'm going to move that 3 over to the other side. So again, when I do that, I'm adding 3 to both sides. And in fact, let's just write that down just in case. All right. And now what I want to do is complete the square on each part. All right, so I'm going to complete the square on the x's, and I'm going to complete the square on the y's. And I have the type of equation where I can add stuff to both sides. All right, so for the x's, my 2p for the x's is 4. So that means p is 2, and p squared is 4. So I want to add a 4 here and add a 4 here. For the y's, my linear term coefficient is -6. So 2p is -6. So I divide both sides by 2. So p is -3. And then I square both sides. So p squared is 9. So I'm going to add 9, and I'm going to add 9. All right, so my x's are going to factor into x plus p. So that is going to be x plus 2 squared. My y's are going to factor into y plus p squared. So that's going to be y plus a -3. So that's going to be -3 squared. And if I add that up on the right, I get 16. All right, so there's my conic section in standard form. From here, again, depending on the conic section, you're going to do what you do. But since I have a circle, right, since this is a circle, I can pull out the center and the radius. All right, so the standard form for a circle is x minus h squared plus y minus k squared equals r squared. All right, so x minus h, I have x plus 2, so h is -2. Y minus k, y minus 3, so k is 3. And r squared is 16, so r is 4. So the center of my circle is -2, 3, and the radius is 4. All right, so there's a nice method for completing the square. Again, it's very visual, and a couple of applications for completing the square.